Thank you for downloading Atypical, the podcast. If you enjoy our work, all we ask is that you leave us a review in your podcast player and share it with your friends. It helps us reach more people, and it's always great to hear from you. Thank you again, and we hope you enjoyed this episode of Atypical, the podcast.
Hello and welcome to Atypical the podcast where we look at life from a more atypical perspective. My name's Simon Heather, your host, and unfortunately, he says it yet again, it's just me. But that's mostly because it's my own fault. I had in fact recorded something with the lovely Kim, but then, well, disaster struck and I had technical issues and, well, let's just say I lost an audio file and then got rather annoyed with myself, nearly deleted the podcast. Anyway, it's been a couple of weeks, and in fact, about half an hour ago, the Prime Minister of Britain announced. I'm fairly certain that his PR people must be asleep at the wheel because I'm not entirely sure that announcing an election for Independence Day is going to do much for the satirists. Did I sound sarcastic enough there? Apart from the blasting of "things can only get better" behind him, which, to be honest, should probably have been "things can only get wetter" given the amount of rain falling on him. A somewhat apposite way of talking about his premiership, I suppose, but still. Anyway, you're not here for Politics Hour, although I apologise now because I suspect it will come up again at some point this side of July. Because, unfortunately, I lost that session with Kim and I can't actually remember everything we spoke about, you're going to have to deal with another paper. Because it's me, I've been reading different papers. But interestingly, I think a few of you might quite enjoy this one. At least I hope so, because if you've got this far listening to my podcast, hopefully I'm doing something right. But anyway, paper I found, and I thought I'd share it, because you all know how autism spectrum disorder, ASD, whatever you want to call it, is a somewhat complex neurodevelopmental condition that affects social interaction, communications, and behaviour. Well, astonishingly enough, researchers have been trying to understand what might cause it. And this most recent study, the excitingly titled Developmental Dopaminergic Signaling Modulates Neural Circuit Formation and Contributes to Autism Spectrum Disorder Related Phenotypes. I really need to get better at pronouncing these things. Anyway, it was published in the upcoming June edition of the American Journal of Pathology, and I'll provide links as always, and it gives some interesting insights into some new avenues of thought. So the researchers have started by looking at human brain data and found that in people with autism, there were changes in the dopamine signaling pathways that seemed to be connected to changes in neural development. Now, obviously, dopamine is a neurotransmitter that plays a crucial role in the brain, and it looks like it might somehow be involved in autism. So we've talked about dopamine before, and when I was quickly making my notes for this, in between celebrating the fact that I might have to go and buy some champagne ready for July, I thought it might be a good idea to cover it off again in a little more detail. So I broke out my Oxford Handbook of Neurology and had a quick read. Dopamine is a neurotransmitter that plays that role in our brain's reward system, movement regulation, cognitive functions such as attention, learning, and memory. It is produced in several areas of the brain, including the substantia nigra and ventral tegmental area. Dopamine acts on 5 different types of receptors, cunningly called D1 through D5, and they are mostly divided into 2 families, D1-like, which is D1 and D5, and D2-like, which is D2, D3, and D4. Might be going into it a little bit farther, but there you go. Because the binding of dopamine to these receptors triggers various signaling cascades that modulate neural activity and synaptic plasticity. Plasticity. I can't even pronounce the words I've written down in front of me, can I? But anyway, dopamine is created or synthesized, if you remember that from your GCSE biology, from the amino acid tyrosine through a series of enzymatic reactions. Once it's released into the synaptic cleft, dopamine can bind to its reactors on the postsynaptic neuron, or it can be taken back up into the presynaptic neuron by dopamine transporters. Inside that presynaptic neuron, dopamine is either repackaged into vesicles for future release or degraded by enzymes such as monoamine oxidase. So dysregulation of the dopaminergic signaling has been implicated in various neurological and psychiatric conditions, including Parkinson's disease, schizophrenia, and our old friend, attention deficit hyperactivity disorder. It also impacts addiction, but I'm going to hold off on that because I'm hoping to do a fuller episode on addiction with a guest soon. Anyway, for example, in Parkinson's disease, for example, the loss of dopamine. Words. Okay, fine. For example, in Parkinson's disease, the loss of dopaminergic neurons in the substantia leads to the motor symptoms such as the tremors, rigidity, etc. In schizophrenia, it's thought that excess dopamine in the mesolimbic pathway and insufficient in the mesocortical pathways can contribute to both those positive and negative symptoms. And indeed, we've talked about it many times in terms of ADHD. Anyway, back to the study that I started talking about. And this was to investigate dopamine-related idea further. And in order to do this, they used zebrafish, which are a common model for studying brain development. When they disrupted the dopamine signaling in these fish during their development, they noticed that the fish had abnormalities in their neural circuits and started showing behaviors that were similar to those seen in autism, like being less social and more anxious. I'm not entirely sure how you can tell that in a fish, but lots of researchers use it. So the researchers doing the study think that dopamine signaling might affect how neurons develop and specialize, possibly by influencing molecules called integrins, which help cells stick together and communicate. What's really interesting is that they treated the zebrafish with a drug that blocks dopamine receptors during early development. The fish showed autism-related behaviors even when they were older. And this suggests there might be a critical window during development when dopamine signaling is really quite particularly important. When they looked more closely at the genes affected by disrupting dopamine signaling, they found changes in genes related to cell adhesion, which is crucial for proper neural development. The researchers think that targeting dopamine signaling during this critical period could potentially be a way to treat or prevent ASD in the future. So I had a bit of a chat with my usual coterie of researchers and PhD holders, and several of them have raised important points about the limitations of using zebrafish as a model for human neurodevelopment and disease. While zebrafish have become a popular model organism for studying brain development and function due to their high fecundity, rapid development, genetic tractability, there are, it may shock you to learn, some significant differences between zebrafish and human brains that might need to be considered when interpreting the results of this and other studies. While it is true that zebrafish lack a layered cerebral cortex and a hippocampus with the same anatomical organization as mammals, I was sent a study that suggests they are functional homologs of these structures in the zebrafish brain. Specifically, the dorsal pallium in zebrafish is proposed to be functionally equivalent to the mammalian amygdala, while the anterior dorsolateral pallium, my God, I managed to get through that one in first go, is thought to be the functional homolog of the hippocampus. Now, the second study I read does seem to highlight that the basic forebrain organization is conserved across vertebrates, including zebrafish. The subpallium in zebrafish is rich in GABAergic neurons and is considered again to be a homolog for the basal ganglia in mammals, which is a key region involved in interval timing. So yes, given these functional similarities, zebrafish may provide some insights into the neurological and neural mechanisms that underlie interval timing and its potential disruption in neurodevelopmental disorders like autism. The various studies have demonstrated that larval zebrafish can learn and anticipate temporal patterns of stimuli, which suggests the fundamental circuitry for temporal processing is present and functional at an early developmental stage. So, while zebrafish and mammals may share many conserved developmental pathways and neurotransmitter systems, including the dopaminergic system, the specific mechanisms and timelines of neural circuit formation will probably differ between species. I mean, for example, the development of the blood-brain barrier plays a fairly crucial role in regulating the central nervous system. It occurs much earlier in zebrafish, around 3 days post-fertilization, compared to humans, where it's embryonic day 23 to 25-ish. But another limitation of the study is the use of pharmacological approaches to disrupt that dopaminergic signaling. So while dopamine receptor antagonists, such as SCH23390, is widely used to study the role of D1-like receptors, it may have off-target effects and may not fully recapitulate that genetic complexity and environmental factors that contribute to ASD in humans. So future studies will have to use genetic models of ASD and a combination of behavioral, molecular, neuroimaging techniques in mammals and humans to properly validate and extend these findings. So, like I say, despite these limitations and the zebrafish model used in the study, it provides some potentially very valuable insights into that role of developmental dopaminergic signaling in autism-related behaviors and neural circuit formation. The conservation of key neurodevelopmental processes and the ability to perform high-throughput behavioral and molecular analysis does make zebrafish a useful complementary model to human and mammalian systems. But as always, caution should be exercised when extrapolating findings from any other animal looking at human neurodevelopmental growth and disease. I don't need to tell you about the fact that, for example, things like thalidomide were safe in rats but caused really quite nasty effects in humans. We always have to take into account that combination of multiple models and systems, and we're going to need lots of different approaches to make sure we can fully unravel that complex etiology of autism. But in a nutshell, the study suggests that dopamine signaling during early development is an important factor and might well play a factor. I've used that word too many times. Might well play a part in that proper formation of neural circuits. And when it's disrupted, it might, and I stress the word might here, contribute to the development of autism. Of course, more research is needed, but I found this really quite a fascinating approach. And it reminded me of a paper I read quite a while ago from 2012. You might remember 2012, London Olympics, the Costa Concordia got some damp carpets, Storm Sandy happened. On second thoughts, let's move on from the year and focus on the paper. Now, this one, the wonderfully titled Treatment for Co-occurring Attention Deficit Hyperactivity Disorder and Autism Spectrum Disorder, deep breath, looked at the growing numbers of people with diagnoses of both conditions and wanted to start a conversation around those potential pharmacological treatments. Now, this study and a much more recent one from this year, which looked at co-occurrence in children, provides some interesting insights and structure to the evolving understanding of the relationship between these two conditions and the implications for, air quotes here, treatment. The 2012 review highlighted the growing recognition of the co-occurrence of ADHD and autism, something which we very much know about today, and also highlighted the diagnostic constraints that often preclude dual diagnosis, which again is something we are battling against even now, 12 years later. I mean, just listen to some of our previous episodes. Anyway, the authors of the 2012 study emphasized the need for further research on developmental trajectories, comorbid psychiatric conditions, deficits in social skills, and executive functioning in individuals with co-occurring ADHD and autism to help inform long-term treatment development. They noted that most treatment-focused research at the time had examined pharmacological interventions with limited studies on psychosocial treatments targeting those co-occurring symptoms. I mean, we've talked about this before. I take lisdexamfetamine, which I think is called Elvans or Vyvanse for my US listeners, to help with my ADHD. I also had a certain number of, effectively, I suppose, counselling sessions which looked at that psychosocial aspect of it. Now, I think that the meds definitely do help me to deal with some aspects of my autism, I will leave it to my co-hosts who have known me for some time, and both before and after I started taking them, to comment further. But the more recent study, which I previously mentioned, also from this year, looking at kids, was looking at the high rates of comorbidity between ADHD and autism, with an argument that further supporting the need for a better understanding of that shared neurobiological underpinning, and saying that we really need to develop some kind of targeted intervention. The findings of this school-based study do align with the observations made in the 2012 review regarding that frequent co-occurrence. And we've talked about the numbers on this podcast before. If you're autistic, you have around a 50% chance of having ADHD. We have around 8% of the population have ADHD. These things do start to add up, and that cross occurrence and dependencies of the different feelings can be really quite difficult to explain properly. But this is kind of what made me start thinking about it, because that Zebrafish study I was just talking about on the role of developmental dopaminergic signaling provides a potential neurochemical link between ADHD and autism. That dopaminergic dysfunction has been long implicated in ADHD. It's why my meds work. And the study does suggest that disrupted dopamine signaling during development may contribute to autism-like behaviors and neural circuit abnormalities. That alone could account for the huge overlap. That presence of shared neurochemical alterations, particularly in that dopamine system, could explain those high rates of comorbidity and the overlapping symptom profiles. Anyway, taking the findings of all of these studies in the round, I do believe that the Zebrafish dopamine study provides some additional support for that argument, the one that I've just made and one we've made in the past. That identification of common substrates in that dopaminergic dysfunction could help bridge the gap between the observed clinical comorbidity and, frankly, the underlying pathophysiology of it all. The understanding could help guide the development of more targeted, supportive, agency-led pharmacological and psychosocial interventions. None of this autism conversion therapy that we talked about previously, but something that actually addresses the specific needs of individuals with the co-occurrence of both ADHD and autism. Like I said, with that Zebrafish study, the findings of any of these kinds of things must be interpreted with a certain amount of caution, and especially when you're extrapolating it towards human neurodevelopment and our own evolution. Using proper research models that include mammals and indeed humans is gonna be necessary to validate those findings. And I'm going to say this again, for anyone who goes and reads the papers, which are in the show notes as usual, that complex interplay of genetic, environmental, and development factors in the etiology of autism and ADHD must be considered when interpreting the results of any single study. And in fact, while I'm on studies and research and avoiding talking about elections, I really want to talk about elections. I do also want to talk about including autistic researchers in autism research. Now, I don't know if any of the authors of the 3 studies I've currently just talked about are autistic, but it's a big discussion point in autism research at the moment. When it comes to conducting ethical and meaningful autism research, it's crucial to involve autistic researchers and community members throughout the entire process. This isn't just ticking a box or being politically correct or woke or whatever analogy you want to use for it. It's about ensuring that the research accurately reflects the experiences and perspectives of autistic people, of the autistic community. The latest edition of Autism, which is published, I think, by Sage, contained an article by Williams and others, which introduces the concept of an insider-only community-partnered participatory research council. I can include a link to explain what those things are. It's a research ethical board. But the idea of this is that all of the members of that council will be autistic. And so this approach takes things a step further than the traditional research councils because it puts the power entirely in the hands of autistic individuals. And the authors of this latest paper, which is in Autism, comes out next month, is that they found that this created an almost unique sense of safety, of equity and collaboration among the council members. And for me, one of the key takeaways is the importance of creating that safe space for autistic knowledge production. Honestly, give me a comfortable sofa, plenty of food, and a library, and I'd be happy for life. But creating and fostering an environment where autistic people feel comfortable being their authentic selves, able to express their thoughts, their feelings, building a sense of community is so important. It's about valuing diverse communication styles and accommodating individual access needs. I was talking to one of my co-hosts, and he pointed out that a crucial point is the need for intentionality in creating accessible and inclusive research practices. We, go back to our second episode where we talked about some of the issues involved in earlier theory of the mind research, for example. We need to be proactively identifying and addressing those barriers to participation rather than waiting for issues to arise. It's about demonstrating a genuine commitment to inclusivity from the outset. And you could include all of this I've just said in almost everything we do in life, in industry, in business, in schools. My co-host also thought it was worth highlighting the importance of fairly compensating autistic community members for their time and expertise when they get involved in research. It's not just a matter of financial equality, it's about showing respect and acknowledging the value of people's contributions. By creating a research environment that prioritizes autistic voices, experiences, and ways of knowing, we can ensure that our findings are more accurate, they're more meaningful, and ultimately beneficial to the autistic community and those who support us. I hope if you're listening and you're part of an organization or you are a researcher looking to advance autistic and ADHD understanding, please take this on board and we will all get some truly remarkable and respectful studies and outcomes, and we can all grow together. That's my 5 minutes of please, please, please work together, because it's so incredibly important. I don't really have a huge amount more to say because, like I say, I'm still annoyed with myself for losing an hour's worth of a good show with Kim, but hopefully we can record another one of those soon. I've also been working with another friend who wants to come along, and we are looking at reviewing media, specifically things that involve autistic or queer characters and the representations and changes over the years. We're hoping to start with Sia's film from a few years ago, which some of you may remember, and think about it in terms of not just the representation it created, but also the philosophical questions that it raises for us. So do keep your eyes peeled for that. We haven't set an exact date for it because mostly I have to actually sit through the film first, and I need to gather my spoons before I can do that. In the meantime, I hope you have a very pleasant weekend. If you are in the UK, please make sure you register to vote. And I'm not going to sing Things Can Only Get Better because I'm not voting Labour. But even so, it's moving on from where it has been, so we can but hope. Do have a great weekend, and thanks for listening again. Take care now. Bye.